Okay, welcome to this short video to take the place of our Class Connect session today. Again, remember the Dropbox assignment or task for participation has been eliminated, so you are good in that regards. So, talking about inequalities, this is 6.04 through 6.06. An inequality is like an equation, but instead of seeing the equal sign that we're all familiar with, it has one of these, meaning less than, greater than, less than or equal to, or greater than or equal to. And remember, it's silly, it's from elementary school, but if you have to draw the little alligator teeth on and think of which way the alligator is biting, it bites the bigger one, that's what you need to do. It's silly, but it works. So, what do inequalities actually mean? You use that symbol to state or express a relationship between two quantities, saying that they are not equal, but one is less than the other, or one is greater than the other. When we graph an inequality, we used a closed or open circle to represent it. And if you can understand this concept about an open or a closed circle, you can get on multiple choice assessments, you can eliminate at least half of the answers. Strange but true. Let me show you. So if we have something like this, x is less than 5, it means it could be 1, it could be 2, it could be 4. What do I mean? Is 4 less than 5? It is. That is true. Is 1 less than 5? It is true. Is negative 13 less than 5? All of these numbers that x could be are less than 5. Now that makes it a little difficult to make a list of all of the numbers it could be. It could be 1.2, it could be 2.7, it could be 1.9999, it could be negative 37.43. It's really hard to make a list that long. So what mathematicians do, because remember they're lazy, is they will say, instead of drawing a little dot at all of the numbers it could be, they will draw a line saying it can be all of those numbers. However, in our example where x is less than 5, can x be 5? No, because 5 is not less than 5. That is not a true statement. So they draw an open circle saying it can't be 5. It can't be right on that number 5, but it can be everything up to that number. And if you're looking at multiple choice assessments, about half of them, the differences will be, is it an open circle or is it a closed circle? If it's a closed circle, it means it can be the number 5. If we had x is less than or equal to 5, we would fill it in. So, in this situation, x is greater than or equal to negative 2. Can we name 10 numbers that are greater than or equal to negative 2? First off, start with negative 2, but then negative 1 or 0 or 5 or 3.7, and we would graph it like this. A nice solid circle because it can be negative 2, and it can be 3, and it can be 10, and it can be 7.1, and it can be 15. Notice what I'm doing when I'm putting in dots for all the numbers that it can be. It creates a solid line. Now, again, if you can understand open and closed circles and whether to graph to the left or to the right, you can get the majority of multiple choice questions right. Do a couple of test dots and say, can 5 be a right answer? Can 15 be a right answer? Ooh, these are right answers over here. Will negative 10 be a right answer? Is negative 10 greater than or equal to negative 2? No, that is not an answer. My line, my arrow will not go that direction. Now, we need to be able to solve these. To do so, we do the same steps that we've done with equations. We undo addition, by subtraction. We undo multiplication by division. We do the opposite, and we'll do it in that order. Primarily do addition and subtraction first, and then multiplication. And remember, if you do it to one side, you need to do it to both. So start with the easy stuff. We'll pick off the weak link in the herd. W, 5 minus 5 makes 0. 8 minus 5 is 3. We solved it. And if we need to graph it, what would we do? First of all, determine whether we have an open or closed circle. We have an open circle because it cannot be 3. This is not a true statement. It cannot be 3, but it could be numbers up to 3. From which direction? Is 2 a solution? Let's see. Is 2 less than 3? Yes, it is. Is 1 a solution? Is 1 less than 3? Yes, it is. These numbers here are all solutions. Let's try 5. Is 5 a solution? 5. Is 5 less than 3? No. 5 is not a solution. Our arrow just goes in this direction like that. And here I've solved it nice and neatly if you want to freeze it or save it. Here's another example. Remember, addition and subtraction first. They're the weak links. Get rid of them while you can. But if we do it to one side, we have to do it to both. 8 minus 8 is equal to 0. Bring down the operator exactly like it is. Negative 2, negative 8 gives us negative 10. How would we graph that? 1, 2, 3, 4, 5. There's negative 5. 6, 7, 8, 9, 10. Negative 10. R is greater than or equal to negative 10. So does this make a true statement? Is negative 10 greater than or equal to negative 10? It does. It can be negative 10. We will fill it in. It can be that number. Now, the question is left or right? Well, let's go bigger. Let's look at 5. Is negative 5 greater than or equal to negative 10? True. Negative 5 is the solution. Let's go lower and see what that works. Negative 12. Is negative 12 greater than or equal to negative 10? No, it is not. We don't go this way. We go this way with our graph. And again, I worked it nice and neat right here for you if you don't like my chicken scratching. All right, one more example. In this example, we don't have any addition or subtraction to do. We will jump straight to multiplication and division. We want to undo it, so we will divide by the opposite. X is greater than negative 2 divided by 2 gives us negative 1. Can X be negative 1? No, it cannot, because negative 1 is not greater than negative 1. So we do an open circle. Can X be 0? Is 0 greater than negative 1? Yes, it is. There we go. This is the right direction. Okay, one more. Here it is nice and neat with addition and division. Pick off the weak stuff first. Get rid of that negative 8. Subtracting it from both sides, we get 2h. 24 minus 8 gives us 12. We want to get h by itself. We want to detach from that 2. It's currently being multiplied, so we will divide to undo it. 12 divided by 2 is equal to 6. 0, 1, 2, 3, 4, 5, 6. All right, can h be 6? Does this make a true statement? Okay, I'm sorry, but I lost power there for a minute and everything went on hold. So I hope that we all came back and everything's good. All right. Uh, so far what we've been doing is what should seem familiar from solving regular equations. However, when we're doing inequalities, there is one tricky thing that you have to be aware of, and it has to do with either multiplying or dividing by a negative number. Let me show you. In this case, we want to get x by itself, so we'll subtract 4. We are left with a negative x. 3 minus 4 is negative 1. Whoa, so we know we want to divide by a negative 1 so we can get a positive x. If we divide or multiply by a negative number, we have to flip the operator. Negative x divided by negative 1 gives us a positive x. Negative 1 divided by negative 1 gives us positive 1. X is less than 1. Don't forget the one tricky thing. If you multiply or divide by a negative number, you have to flip the operator. Let me show you again. We'll want to subtract 5, so we'll subtract 5 from both sides. We're left with a negative x is greater than 3 minus 5 is negative 2. We want to get x all by itself without that pesky negative. Negative divided by negative gives us a positive. We have to flip over the operator to the other direction. Negative 2 divided by negative 1 gives us positive 2. And then we would graph it just like the others. Here's 2. X is less than 2. In this case, we'll have to do a couple of steps. We need to isolate the variable by getting rid of that 4. Negative 2x, negative 6, negative 4 gives us negative 10. We'll want to divide by negative 2, but again, if we divide by a negative number, we have to flip the operator. Negative divided by negative. Negative 10 divided by negative 2 gives us positive 5. Don't forget to flip the operator. One last one. 5 minus 3x, we'll want to subtract 5 from both sides. 5 minus 5 is 0, so we're left with negative 3x. Negative 4 plus a negative 5 gives us negative 9. We're dividing by a negative number, so we have to flip the operator to the opposite direction. Instead of going this way, it now goes this way. We're left with negative 9 divided by negative 3, positive 3. All right, those are the tricks where inequalities are concerned. If you have any questions, send me a K-mail, stop by Live Help. Enjoy your week off from a Class Connect session, and I will see you next Tuesday.